All right, welcome everybody to 12.2 Combinations. So today we're going to build off of what we learned in section 12.1. Remember, in section 12.1 we had fundamental counting principle and permutations. Permutations was when I selected a group of things and I arranged them in a certain way. Now today we're learning about combinations. Combinations is when I take a selection of items. Again, I'm going to select some things out of a big group of items. And for this, order does not matter. Order does not matter. So permutations, order matters. Combinations, order does not matter. And here's our formula for combinations. It is NCR, C for combination. N still stands for the number of items in the large group. R still stands for the number of things I'm selecting out. We're just not arranging them this time, we're just selecting them out. And here's our formula. On top of the fraction bar, n factorial. On bottom of the fraction bar, n minus r factorial, and then r factorial. So a little bit longer than the other formula. Make sure you have that written down correctly. Here's how combination works. So here's example 1. There are 7 musicians, each playing at a competition. Top 3 performances win a $100 prize. How many ways can the top 3 performances be chosen? So this is different because when we did permutations, they specifically asked for first, second, and third place. So specifically different places or arrangements of the performers. This time we just want to select 3. So my setup would be 7 combination 3. So n is 7 and r is 3. And if you wanted to type this all in, you would make sure to put that bottom part in the top in parentheses if you're going to do that part in your calculator. We do have a combination button as well, though. Let me show you this longhand a few times before we go to the calculator. 7 minus 3 is 4 factorial on bottom. And now if I wrote this all out, we talked about this last time. Some of my stuff is going to cancel, but this one is going to have some extra stuff left over too. So 4 and 4 cancel, 3 and 3, 2 and 2, 1 and 1. I this time have something left on bottom still, and that makes it so that combinations has less than a permutation would have. When I type that all in, you end up with 35 for your answer. So 35 ways they can be chosen. I want to show you something really quick, and that is when you look at your calculator, I want you to see the difference between combination and permutation. So if I did 7 combination 3, that's what we just talked about. It's 35. So 35 ways I could pick 3 people. If I did 7 permutation 3, whoa, 210. And there's always more for permutations because permutations are arranging them as well. Permutations select and arrange. Combinations just select. Let's keep going. Example 1b. A theater is staging 12 different plays. You want to attend 3 of the plays. How many different combinations of plays could you attend? So there's 12 in the large group, and there's 3 that you want to go to. And we know it's a combination and not a permutation because it just says I'm attending them. It doesn't say anything about ordering them or arranging them. And so if I'm going to use my formula, 12 factorial on top, on bottom, 12 minus 3 factorial, 3 factorial. So if I was going to type this into my calculator, don't forget to use your parentheses. Make sure you get the correct answer. Go ahead and try typing it in. Pause if needed. You should end up with 220 for your answer. Again, write down questions if you have them. Today we're going to be working on more complicated problems than we did yesterday, and C and D are good examples of this. So look at example C. A restaurant offers 6 salad toppings. On a deluxe salad, you can have up to 4 toppings. How many different combinations of toppings can you have for a deluxe salad? So here's what's a little annoying about this. If I can have up to 4 toppings, it means I could have 0 toppings, or 1 topping, or 2, or 3, or 4 toppings. What this means is we're going to need to have a different combination to represent this. So I could have 0 toppings, or I could have 1 topping, or I could have 2 toppings, or I could have 3 toppings, or I could have 4 toppings. When you're doing a problem like this with lots of different combinations, I would recommend use your calculator. Write down your setup, of course, write down your setup, but then you could use your calculator to evaluate these. And if you type in 6 combination 0, 6 combination 1, and all those, here's what you end up getting. It's 1 plus 6 plus 15 plus 20 plus 15. Add them all together and your answer is 57. So there's 57 ways you could select toppings if you could have up to 4 of them. Let's read D. From a group of 20 volunteers, you are choosing at least 18 to be peer counselors. I want you to think for a minute. Can you figure out right now, if it says at least 18, what do you think that might mean? If it says at least 18, what do we want? What are we looking for there? Hopefully in your mind you're thinking, I want 18 or more. So I would be happy with 18 of them. I would be happy with 19 of them. I would be happy with 20 of them. I don't want any less than 18. I want 18 or more is what at least 18 means. Okay, struggling with spelling volunteers right there. All right, there we go. So now I want to choose 18 people out of the group. I want to choose 19 people out of the group, or I want to choose 20 people out of the group. So in the 20 combination 18 situation, that's 190 ways I could pick 18 of the people out. If I'm going to choose 19 of the volunteers out, there's 20 ways I could do that. Type that into my calculator. And if I'm going to choose all 20 of the people, there's only one way I could do that, and that's choosing everybody. Add them all together, and I get 211 ways I could pick those volunteers. So now in this situation, I put plus signs in between because I wanted this to happen, or I wanted this to happen, or I wanted this to happen. In the next situation, I am going to do where we have something happening and something else happening. And the key, you kind of want to think about that as our key words to think about. Like this, I wanted this or this or this. Here I want something and something to happen. Look at example 2a. You are taking a vacation. You can visit as many as 5 different cities and 7 different attractions. Suppose you want to visit 3 cities and 4 attractions. How many different trips are possible? So I want to tell you that this problem is actually very similar to fundamental counting principle. Remember what we learned yesterday? If I have different categories, I have one blank for each category. So I have the cities category and I have the attractions category. Now what we learned in 12.1 was if I had different categories, in 12.1 we're only selecting one thing from each category. So let's say that I was doing 12.1 right now. If there would be 5 ways to select a city and 7 ways to select an attraction, that would be what we learned last time. Now here, I'm still having a cities blank and an attractions blank because they're different categories, but I'm going to pick more than one out. So I'm going to use a combination, and that's going to represent, instead of just picking one city out of the group, I want to pick 3 cities out of the group. And using 5 combination 3 will count how many ways can I pick 3 of the cities to go visit. For the attractions, I want to pick 7 out of the group of 4. Or sorry, 4 out of the group of 7. So out of the 7 different attractions, how many ways could I pick 4 of them is what that combination works. And in your mind, you want to think, I want to do this and I want to do this. So I'm multiplying them. So I'm picking out a different categories, multiply them, and I end up with 350. Again, if you're wondering how I magically come up with these numbers, I'm not magically coming up with them. I did them in my calculator. I just did them ahead of time before making this video. So for example, 5 combination 3 is 10, 7 combination 4 is 35, and then I've just multiplied them. Look at part B. You are taking a vacation. You can visit as many as 5 different cities and 7 different attractions. Same situation. But now this time you want to visit a total of 8 locations. And how many different trips are there? So now we're not distinguishing between cities and attractions. We're not making them separate categories. We're throwing them all into the same category. So there's 12 total locations if I think about 5 cities and 7 attractions. I want to visit 8 of them. And it doesn't say anything about arranging or order or anything, so that's how I know it's a combination. So I have 12 places to visit. I'm selecting 8. 12 combination 8 is 495. And as a matter of comparison, I keep talking about permutations, but I haven't shown you an example for a while. Here's what a question would look like for a permutation question. Now I'm asking, in how many different orders could you pick and visit 8 locations? So here I'm just picking 8. I haven't said anything about what order I'm going to go see the stuff in. Now I'm picking 8, but I'm also going to rearrange them. That is when you use a permutation. So here, order matters. The order I visit the places mattered when I'm counting how many. Here, it didn't matter what order. I'm just visiting them in general. So 12 permutation 8, 19 million, I use my calculator, 19,958,400. As soon as you have that down, flip to the back. Example 3. A restaurant serves omelets that can be ordered with 6 vegetables and 4 meats. Suppose you want exactly 2 vegetables and 1 meat. How many different omelets can you order? Alright, this is another situation where I have 2 different categories. I want this to happen and I want this to happen. So I want veggies to happen and I want meat to happen. So again, different categories have different blanks. I want to say, how many ways can I choose a veggie? How many ways can I choose the veggies? Because I'm going to get 2 of them. So there's 6 total to pick from. I'm selecting 2, so 6 combination 2. And then for the meat, there's 4 to pick from, and I am selecting 1, so 4 combination 1. I end up with 15 times 4, so 60 ways I can choose an omelet. And now let's go back, let's compare that with example B. Here it says same situation, 6 veggies, 4 meats to pick from, but now I want at most 3 ingredients. How many different omelets could you make? So this situation is when I want at most, so I either want 0 ingredients to happen, or I want 1 ingredient, or I want 2 ingredients, or I want 3. So I want at most 3 of them. So 10 combination 0, 10 combination 1, 10 combination 2, and at most 3. So that's where I stop. So in your mind you're thinking, I want this to happen, or this, or this, or this. They're going to happen differently. Like I can't have 3 ingredients and have only one ingredient at the same time. Like it's just not possible. So this, or this, or this, or this. Whereas here I could have both at once. So it was an and situation. When I figure that out, here's what I got for my combinations. When I did that with my calculator earlier, I typed it all in and add them together, and there's 176 total omelets that you can do. Alright, we have 1 example left, and I'm going to have to go to another video to make that happen. So this is it for part A. Thanks for watching.